Advanced function, lesson 5. In this video, we are going to talk about rational zero theorem. P at x is a degree n polynomial. That means P at x is a n xn plus a n minus 1 x to the power of n minus 1 plus a to the power of 0. A n xn in this polynomial is called the dominant term. And a n is called the leading coefficient. A0 is called the constant in this polynomial. And the others are called the coefficient of the related term. For example, the coefficient of x to the power of n minus 1 is a to the power of n minus 1, and so forth. If x equals p over q is a root of this polynomial, then we can prove p divides a0 and q divides an. In other words, p, the numerator of the fraction, divides the constant term in the polynomial, and q, the denominator, divides the leading coefficient. For example, let p at x equals 2x3 plus 5x2 minus x minus 1. Can 2 be a root of this polynomial? In other words, can p at 2 equal 0? The answer is no. 2 is a rational number, therefore 2 is a rational zero of p at x if p at 2 equals 0, which is not possible because 2 doesn't divide negative 1. Let's list possible rational zeros of p at x. Plus minus 1, plus minus 1 over 2. The numerator is the divisor of negative 1, and the denominator is the divisor of 2. Let's make this a little bit more clear. This doesn't mean these are the roots. This means if p at x has a rational root, that root cannot be anything but plus minus 1 and plus minus 1 over 2. Let's have another example. Let's consider x3 plus 7x2 minus 11x plus 3. What are the possible rational zeros of this? The leading coefficient is 1. The constant is 3. It's a polynomial degree 3. Plus minus 1, plus minus 3 are the only possibilities. Now, how do we know if it has any rational zero? We start plugging this number in. Whichever makes p at x equal 0 is the root. And if none of them is making p at x equal to 0, that means the equation does not have any rational zero. In this case, p at 1 is 0. That means x minus 1 is a linear factor. And that also means this equation has a rational zero. Let's factor p at x quickly. P at x can be written as x minus 1 times a quadratic polynomial. Obviously, the first term is x2, and the last term is 3 if we rate the quadratic trinomial, because x times x2 gives us x3, and negative 1 times negative 3 gives us plus 1. So it should be x2 and negative 3, not plus 3. Now we are looking for the middle term. The middle term is a number times x. We are looking for that number, the coefficient of x. If we times negative 1 by x2 and x by ax, we assume the coefficient is a, we have negative 1 plus a times x2, which is 7. The coefficient of x2 on the other end, on the other side is 7. That means a is 8. P at x can be factored as x minus 1 times x2 plus 8x minus 3. Let's multiply this and confirm it. X times x2 is x3. X times 8x is 8x2. X times negative 3 is negative 3x. Negative x2, negative 8x, and plus 3. If we collect the like terms, we have x3 plus 7x2 minus 11x plus 3, which is the original polynomial. To recap what we've done so far in the course, we talk about the division, the remainder theorem, and the factor theorem, and also the rational zero theorem. Thank you.